is they allow you to reduce concurrency, to reduce the crowd that can get into the critical section. While with a mutex you can say only one can enter the critical section, with a semaphore you can say at most 5 can enter the critical section. So semaphore is not really mutual exclusion, it's more like crowd control, not too many. So you may imagine situations where you have threads performing really complex calculations and you have a bunch of them. But you don't want to overwhelm your computer, let's say, and then you can put a semaphore saying, well, you know what, no more than 3 should do this at a time. So that would be a semaphore. Or if you want to, maybe you have an old printer that can print concurrent jobs, but it has a limit. If you send too many, it will lock up. So then you put a semaphore and say, you know what, no more than 7 simultaneous jobs, because the printer locks up. So you control the amount of concurrency. Obviously, if you say no more than 1 can go in, the semaphore becomes a mutex, or like a mutex in functioning, and it's called a binary semaphore. So let's see how this works. We declare, what do we have here? It's something very simple. We have a function that waits 10 milliseconds, and we use it here just so that the example is a little slower and we can see what we need to see. And then we have a bunch of functions that we create 50 functions, 50 threads, and all of them try to get through the semaphore. And when they get through, they print out how many spaces are free inside, and then they stay a little bit and then they go. So we initialize here the semaphore and we say at most 3 positions, right? Then we create 50 threads, then we wait for the threads, and then we destroy the semaphore. So the crucial part is that we say initialize with 3. And then the functions do wait and post. So you may think of this as you have it today with this virus. Many pharmacies and shops say no more than 3 people inside. So this is a semaphore. You get to the shop and you wait. If the semaphore is above 0, meaning there are more spaces, you go through. If not, you sit there until a position is freed. Once you get in, now what you do here is you print something, you stay a little bit, and when you go out, you post, meaning you release the position you occupied. The wait you can regard as a reserve, as a get me a free position, or wait until one is available. Once you got it, you do what you need to do, and then you release it. You post it back to the semaphore. And then another can go in. Another wait can go in. Can we change the number of things allowed through the semaphore during the program? I think you can. I don't know if you can do for these. It's a little odd to do that though. But there are ways. Let me just see a little bit what API we've got. So a way to increase is just to post for no good reason. All right, you just post a few more values. But I don't know why you would do that. Yes, you can use semaphores instead of mutexes if you initialize them with 1, and then they are called binary semaphores. And here is the example that does that. Right here. This is the example from the very beginning. But instead of having a mutex, you have a semaphore initialized with 1, and then you wait, and then you post. Mr. Steff, so basically it's a kind of a queue. Yes, it is a kind of a queue, but a queue involves an order, while here there is no order. the operating system will check who gets to go next based on the priority of the threads and a number of other aspects, how much processor they got until now, and so on. So although the processes who wait at the semaphore will sit in a queue, their order does nothing about who actually gets to go next. The operating system chooses that. All right, so if I am to just run this program a little bit to see what it does, although I think you kind of got it already. What you see here is that initially one thread goes in. So as soon as it goes in, it prints out that there are 2 more spaces. Another one goes in, it prints out that there is 1 space left. Another one goes in, no more spaces. And then somehow all 3 get out before others can get in. So again, you have this, and it keeps going. Now here, what happens is one thread goes out. Actually, 2 threads go out, and one goes in and says, look, there is 1 space. You see? So it's kind of like a crowd trying to get in, and it's all chaotic, but what is enforced is no more than 3 inside. Yes. Sorry, I didn't explain. Yes, get value just tells me what's the value of the semaphore so that I can print it out. I'm using it only to sort of give you some insight in what's happening. But normally you only use wait and post. That's all you need. The rest, this is rarely used. Very much like in this example, wherever it may be. Right, very much like here, just wait and post. And then the initial value of the semaphore determines how many can go through the wait. How unrecommending is using mixed synchronization? Well, this is a very general question. How do I go about it? You don't use synchronization, for, taste. Synchronization is not something that you do optionally. And the choices that you make are not always really, you don't always have alternatives. So what you do is you just need to choose a sound, logically correct way of bringing order where it needs to be. You will have to use, you saw, mutexes with conditional variables. You will have sometimes a need to mix mutexes with read-write locks. You will probably need a barrier every now and then. You use what needs to be used and just make sure you do it right. And you'll see next week when I'll do examples what can happen. Because what can happen is your program can lock up if you are not careful. But that's not because you're mixing synchronization mechanisms, is because you are using them wrongly and you just need to fix the way you're using them. So yeah, you can mix as much as you want as long as it's logically sound. Water addict, can you please explain the second argument in Seminit? Yes, I actually, you didn't miss that part because I didn't say it. That argument, let me bring the manual. You might see it if we have time in the seminar. That argument says whether the semaphore can be shared across processes. You see that? Be shared. And somewhere this. So these semaphores are designed to work with threads. But what you can do, you can put a semaphore in a shared memory area between processes. And then processes can synchronize among themselves using this semaphore in the shared memory. But for the semaphore to be accessible to different processes, not just threads within a process, you need to initialize it with a 1. in that position. All right. Now, process synchronization can be done using IPC semaphores, and you've seen that there are, but I didn't go into them because the API is a little more complex. You can also synchronize them using file locks, but you can also synchronize them using thread mechanisms stored in shared memory across processes. Yeah, awesome. All right, so guys, that's about it for today. If there are questions, go ahead. I will just have an announcement to make about next week's tests. But first, I would like to get through whatever questions you may have regarding these synchronization mechanisms. um, I am not aware of an evil mode in Emacs. Emacs is totally holy, so I don't expect anything evil out of it. I'm just using the regular key bindings. I have defined a few of my own, but I'm not very consistent with them. Sometimes I transfer the config file, sometimes I don't. I've got a lot of, I configured my colors, and I have no on this installation. I don't actually have any shortcuts. Oh, evil. No, no, no. I'm not. I'm more of an Emacs fan than a VI. So I prefer the Emacs bindings, but I kind of used to both. So I just adapt to whatever editor is in front of me. All right, so no more questions about this. If you do get questions, please type them. No, Pearl Monker, you can't really make barriers lose their patience. Uh, that's really a human trait, very much related to emotions. And I think we created processes initially so that they don't have emotions. Now we're trying to build them in. So no, barriers will wait forever for the late threads. So you have to pay attention to this because they will be able to lock up your system, especially if those threads crashed. So next week, during the class, we will do examples of threads and synchronization with, and we'll bump into deadlocks and we'll see what's going on there and how we deal with it. And we also will have tests next week. No. If you want that, you're not going to use a barrier. You're going to need some kind of timeout. And as far as I know, the barrier implementation doesn't have a timeout. Holly, sorry, I'm actually thinking of strawberries apparently. So I don't see. Maybe let's see if there is something. No, there doesn't seem to be anything that involves a timeout. And what you want is a timeout, so that after a while you give up. For that, you'll have to bake your own solution. Barriers will not do that for you. So next week, tests, grepsed awk, and shell, all in one shot. Your lab professors probably did rehearsals with you, with connecting to the exam server, showing you how things are working. You need to make sure you have a good network connection, have your camera working so that we can monitor you, share your screen, log in with PuTTY, solve the problems. The problems will be a bit on, not necessarily on the complex side, but rather the time will be shorter. This is a measure that we're taking to to discourage cheating, which in this situation will be almost inevitable, but we try to reduce it. It is my job to make sure that after I see the grades in, if they're too low, to adjust them. But for now, I will be testing you guys to differentiate between those who studied and worked and those who didn't. And then the grades will reflect that, but they may turn out to be really low, and then eventually I will scale them to be better. If you didn't do rehearsals, don't worry. The tests will work just fine. The system has been tested quite a lot, so I don't expect you to have problems. Just need to have access to your school email, where you will get the login details, and then be good with the command line. Yeah, if everybody gets a 7, if the greater the top grade is a 7, I'll go scale them linearly, something like that. But I don't expect it to be the case. In this kind of examining, I expect the grades to be lower, and I'm trying not to have you penalized for the virus. But I do have to make sure that the exam is as relevant as possible. But you will be using, Mr. Steff, both the OBS and the website, I think, because I want to see your camera and I want to see your screen as well, both. I don't know how OBS does that. If it can do that, yes, we can do that as well. I don't mind it. I'll try that too. Essentially, we will want to see your screen, your face, and we will also record whatever you do in the command line and review that if we feel necessary. Everybody get the 5. Okay, I really don't try to mess with the system, because I'm the system right now, and it's only me and you guys are 400, so it's not fair. Keep it fair for yourselves as well. I know the time limit will be a stress factor, but don't over stress about it. It's gonna be 2 tests, adding up to maybe a point of the final grade. So it's not the end of the world. You have several tests, okay? That's why there are so many. So if you mess up one, you'll get better in another. So don't overstress. Look at the curves. I posted on the website. It's only apparently a disaster, but in the end it turns out quite good. So just enjoy life, take your operating system exam, and be happy. You see? Grades are quite good. So trust the system. You're going to be very sad. Well, some people will be really grab and even awked, but we'll see about bashing people who are sad. Okay. Are you still allowed to use a cheat sheet? The cheat sheets were only meant for the written exam. So for the practical exams, it's only what the command line provides, meaning manuals. For the written exam, I have to figure out how to do with the cheat sheets. I'll let you know about that. All right. Anything else? Any other questions? Yes, you have, man. You. Oh, thank you, Arquitectuo. You do not have time to learn how to program right then and there using the manual. That is very correct. You don't have time for manual to learn it right on the spot. You have time for the manual to just check, what's the parameter that I have to use here? What option do I have to use here? You don't have time to read the manual and figure it all out from scratch. So you do need to work ahead of time to get some experience to solving these problems, and then you should be fine. I think it will, well, substring of a string, depending in awk, I think you'll find that. But I don't think you'll find the full-blown regular expression specification in the manual, so you have to know a little bit about those. More practice problems, I think if you've gone through these, you should be quite good. I mean, these are heavier and more complicated than what we're going to ask, so I don't think you need more than that. But I'll ask my colleagues. We have a lot of problems. We'll post a number of them. Sure. All right, guys. Anything else? Oh yeah, apparently yes. Awk is a Turing complete language, so yeah, it's better to prepare a little. Yeah, awk is like C, but a little simpler. So do prepare a little. I mean, hello, it's a test. It's not movie viewing, right? So you have to prepare a little bit. That's the whole point of it. So yeah, do prepare. It feels like we're done for the day. Autocomplete. Well, if you can configure VI to do autocomplete for you, yeah, sure. All right, so we stop here, and good luck next week. We'll see each other, hear each other in the seminar and lecture, and possibly even in tests. Everybody have a great day. Enjoy the rain, I guess. At least that's what's going on here. And stay healthy. Bye, everyone.